Hello everyone, welcome to today's deep dive. In this new series, we'll explore the Google file system, also known as GFS, a system which was introduced back in 2003 to handle Google's rapidly growing data needs. But don't worry, we'll break it down into small parts with real world analogy so that it's easier for you to understand. And even if you are new to distributed system, so let's start with a small story first. So imagine you own a small, cozy bookstore, right? You got one shelf that is neatly organized with the books. You know where each book is, right? There's a proper ledger to track every sale. Customers come in, buy books, leave happily, and everything runs smoothly, right? Seems like an ideal scenario, but uh, then a famous author launches a new book, and suddenly your store is packed with customers, right? Wanting that particular book. The shelf overflows. People are waiting. Some books go missing, and you are scrambling to keep track of what's sold and what's not. So you try. So to ideally to solve this, you'll probably add one more shelf, right? Or maybe a couple of more shelves, even outside the store to handle the traffic that you are getting. But now with more shelves, it increases the chaos, uh, and it gets even worse, right? Now customer won't be able to find books, right? Even you won't be able to find books because there are too many shelves. uh, you are not able to maintain properly your ledger entries, and eventually your system starts falling apart, right? So this is what happens with the traditional file system when they try to handle massive amount of data. So in next section, we'll see what are the issues that are faced by traditional file system when they try to handle huge amount of data. So as we saw earlier, how our bookstore started to fail when there was a very huge amount of traffic or load on the bookstore, right? Uh, Traditional file system also works in a similar fashion. Like it also faces similar problems when you try to handle large amount of data. There are primarily five problems with traditional file system, right? First one is limited capacity and scalability. Next one is single point of failure. Another one is slow access and bottlenecks. Then next is inflexible with different data types, and the last one is manual handling of failures. Let's go through one by one to understand how exactly this is a problem, and how can you maybe relate this to our original bookstore problem, right? So first one is limited capacity and scalability. So just like your bookstore, you had only one shelf, right? A traditional file system is also designed to handle small amount of data. It runs out of space very quickly. So anyone's obvious answer would be to adding more disk or more server sites. That's exactly like adding more shelves, as we discussed earlier. It would lead to more chaos and it would be more error prone. Okay. Uh, okay. Next, second problem is single point of failure. So in the original bookstore, you as the owner knew everything, basically where exactly each book is kept, and customer would come and ask to you, and you would fetch that particular book from particular shelf. Right. uh, Now let's assume a scenario that you fall sick, right? Maybe you send someone else, but that person doesn't know very well. Customer are not able to find books. They eventually leave your bookstore unhappily, right? Similarly, in traditional file system as well, if the central server crashes, the whole system can go down, leading to downtime or even data loss, right? Third point, slow access and bottlenecks. Customer asking you where every book is, then you are running from shelf to shelf is slow, right? traditional system also get slower when handling large file system, or where many users try to access the same data at once, right? I mean, think of it like there are hundreds of customers waiting in line to get the book. Each one of them is asking you, you are going and fetching the book and giving them. This is very slow process, right? It would create bottlenecks. Next point is inflexible with different data types. So your bookstore was built for simple books, but what if customer wants magazines, comics, collections, newspapers, etc. Right? Uh, it so it would probably as a traditional file system, it probably won't be able to handle such type of use case, right? I mean, basically, so traditional file system are often built for small and structural data, not for the unstructured, massive, and varied data that modern applications deal with, like images, logs, videos, etc. Right? The last and the final problem is manual handling of failures. Let's say if a book is lost or damaged, you reorder it manually. It takes time and customer has to wait. In traditional file system, handling failure is often manual too. There's no automatic replication or a recovery mechanism. So, as we can see, traditional file system just don't scale well, right? Especially when you're dealing with terabytes or petabytes of data. Okay. Um, Now let's return back to our bookstore example, right? So the demand is booming. Customer wants variety of books, right? They want magazines, newspapers, comics, different types, right? And things need to run efficiently, right? So, what if your bookstore becomes part of a global chain? What do we mean by global chain, right? So, every book is digitally tracked. There is a real time inventory. If one branch runs out of stock, it gets books from another instantly. There are multiple copies of each book maintained across different branches. Right? If one branch fails, no problem, right? Your other branch continue working, and your customer can basically go to a different branch and get their books. So this way, everything would work, and seems like a good solution. So that's the core idea behind building the Google file system. GFS was built from scratch, not to run on perfect machines, but to survive failures, handle massive data, and scale across thousands of machines. Right? It powers services like Google Photos, YouTube, Search, Maps, storing and serving petabytes of information daily. So in this video, we understood why traditional systems break under scale and the need for building a new kind of file system. In the next episode, we'll look at how GFS works internally, from chunking mechanism to replication and the role of the GFS master. If you found this helpful, do consider liking the video, subscribing, and leaving a comment. It really helps me keep going. So, see you in the next part where we build the future of file systems brick by brick. And if you have any doubt or any suggestion for any future topic, please do add them in the comment section. I'll take a look at it. Thanks.